Alright, trying something slightly different format-wise. Let's see how it goes. The frame rate on this camera was a little low, so I don't know if I can do this and it'll work. But we'll see. Try recording the video and then I'm going to try streaming. And anyway, we'll see. I might have to switch to the other computer and get the Windows version of that OBS, I guess it's called. It's interesting enough software. Anyway, so I think it's a better way to read comments anyway, so then you can see the comments and watch me poorly read them. But whatever, it doesn't matter. So anyway, first, synchronicity strikes again. Okay, I have no idea what that means. Won't bother. Thank you. Not really. Anyway, James West. Okay, I like your push theory of gravity. It works much better in three-dimension real world. In the three-dimension real world. I guess dimensional would have been better. And your shadow theory explains attraction so well. Yeah, the catch to that is that the Wikipedia page in describing Lesage gravity, well, maybe I can actually get there without too much trouble. See if this works. Yeah, I'll see if it's sorry, I have to check to see if what I'm doing is actually working. Alright, so they have that part at the bottom that says the nature of collisions. You can't see the nature part, but it's there anyway. And in there they're describing it as particles bouncing off, and yeah, that doesn't work because then the shadow is lost because the particles bounce off, and then they have them at variable speeds. So these are all the conditions. Like, you can set something up to fail by creating assumptions that aren't necessarily assumptions of the actual theory, but are just assumptions they place into the theory to say this is what the theory assumes, and therefore it can't work. And they don't make any effort to describe any circumstance where of course it would work. And what would fix it, simply, if I can move the mouse over here, is if these arrows are absorbed based on how many come in. So if you have extra arrows coming from one side, or let's go top to bottom, if you have more arrows coming in from the top than you have coming in from the bottom, it means a higher percentage of the top arrows will get absorbed than ones coming from the bottom, and therefore the object will move in the direction of that absorption. So that's a key difference that they don't, like I said, they just assume there's no solution. No, there's a simple solution, and fixes the problem. So anyway, not that that's part of your point here. I just wanted to point out how it fits in lots of ways, and it fits in lots of even under detailed scrutiny. Alright, that's the electric universe one. Here we go. Shadow theory. Okay, just a thought. If the push force of gravity can be shadowed, like I said, it's a tricky word to say shadow. The shadow is because something else absorbed it, therefore it can't go where it was going. So it's delayed in getting where it's going. So it's, you just imagine that the Earth is a big piece of glass, and and that, let's say, a big round piece of glass, and let's say light didn't go just 40% slower when it went through. Let's say it went 1,000,000 times slower, and so you can understand that energy could go into it like light or photon, and it would spend a long time in there and then come out. And that delay would mean that the object the photon was going to hit, it doesn't hit it when it was supposed to, so to speak. But anyway, and the delay is really what the velocity is. So if the object gains velocity, that means it's possessing the force. That means the photon's still in there. If it loses velocity, then it has to release the force. So as long as it's gaining velocity, it's gaining force. And since the Earth is in perpetual acceleration, it's constantly gaining velocity and eventually losing it, but it has a certain amount it always has. So it's always denied the sun a certain amount of energy from getting there because of the motion towards the sun. Alright. Alright, if the push force of gravity can be shadowed, do you think it would be possible to shadow the force of gravity in such a way to overcome it, as in anti-gravity? Yeah, well, the trick is it's a lot of force, so you know, it's doable, but it's the same energy problem. You have to create a huge thing that can dampen or absorb a huge amount of energy, and maybe it can shoot it in some other way. Maybe you can make it go somewhere else, okay, where it's not going to disrupt what you're trying to create, which is the anti-gravity. But the energy's got to go somewhere, so that's the catch. So you have to absorb a huge amount of velocity to create anti-gravity, and the velocity has to go somewhere. So that's going to be the problem. I mean, velocity in this way is with a counterbalance to gravity this way. That's the catch. Your motion this way is essentially exactly doing that. It's creating another mechanism, another way to shoot the energy to counter the gravity. So velocity is anti-gravity in a way. Velocity perpendicular to the gravity. And just another puzzle piece that fits from this theory and explaining things is this like logical conclusion that if you're absorbing the energy and shooting it perpendicular to the gravity, that you are deflecting the gravity in a sense, using up the energy of the gravity. So anyway, it just works out well, as I have pointed out. So, James West again. Some of the electric universe stuff is very non-science, but when they get into how plasma fits into how things work, see, plasma is just, it's kind of hypey stuff, okay? You're back to the Tesla kind of science, the science of show. And, plasma really isn't anything but your anode, degrading, creating actual ions and molecules and atoms, essentially, not only just electrons, that end up moving, okay, in the vacuum. So the vacuum is essentially filled by the degrade of your anode, and you create a stream that's very slow and wobbly and all this kind of stuff because they're a bunch of hot atoms. And so it looks interesting, but it's not classic electricity. It's a very unclassic form of electricity where you're essentially breaking the material into a bunch of little pieces and then having the electrons go between the little pieces, essentially with little sparks. So it's like a bunch of little sparks. But it has this illusion of it being like it's ending up going somewhere, but it's just not too sure where it's going. But anyway, it's more show than real hard physics. Alright, and the importance of electricity plays in the explanation of how nature worked. It's very interesting. Well, again, I think electricity is the least interesting in terms of physics, in the sense that it's not really a force. It's a byproduct. Magnetism is causing the electrons to move. Charge. Polarization. And without that, there's no electricity. So, it's the movement of electrons by the quanta, the gravitons, whatever, the magnetons, the photons, the energy between the electrons. It's the energy between the electrons that moves the electrons. And it's that energy that creates the stream of electrons that you think of as electricity. So what's more important, the water in the stream or the boats going through the stream? You know what I mean? We really wouldn't call the boats the force. The force is obviously the river that the boats are getting moved by. And that's how I would analogize it, that you can't really talk about the electrons moving being a force, because they're really being moved by a sub-force, a force a step lower. And that force is, as stated, they're all the same things. It's the little force bits, and they can be in the form of photons, they can be in the form, at bits at a frequency, or they can be bits just polarized, or they can be mixed bits. But I'm just saying they're the things that move electrons. The bits. They're the river. They're the force. Alright. It's very interesting. They also explain where mainstream science is wrong with its over-reliance on using gravity to explain the workings of the universe. Well, frankly, it's not an over-reliance, and certainly by my theory, making distinctions between these forces and saying one is the primary force and the other is a secondary force really doesn't make any sense, because it's all the same force. And the only time you call it electricity really is when it's doing the magnetic thing, which is the segregation of the force, which creates the potential for you to move the electrons. You can't move the electrons if you throw both polarizations at them, because then that's a net attraction plus repulsion equals nothing. So you have to have, they have to be segregated for the force to have effect. And so gravity is essentially magnetic because it's moving electrons, protons, and neutrons. It's not moving the big matter. It's moving the nuclear matter. But it's that key thing where gravity is not segregated force, so therefore it can't do the repulsive thing. So it's only left with the weak attraction. Alright, anyway, workings of the universe. So again, to call the universe electric is kind of To call it magnetic is To call it gravity is because it's all the same force, and it just really depends on how strong the polarization is. That is, the segregation of the force bits, the two kinds of polarization. The more you segregate them, the more potential they have to do work. Trying to use gravity to explain everything just don't work. Well, I think it does work in the sense that the first thing that exists is the huge mixed field of little bits in the universe. The background radiation, quote unquote, which is a subject I want to get to. I should have said that in the beginning of the video. That's really the purpose of the video. But that is the first force, if you want to call one of them the first force, and the rest of them are just modifications of that force. A photon is a modified bit of gravity. Magnetism is a modified bit of that field energy. Alright. That's why they need to invent stuff like black holes, dark matter, dark energy, and many other weird BS. Now, I don't like black holes as just a generic statement. Okay, that I'd say is a little dangerous. The idea of having denser matter, I'm not opposed to. Certainly, the idea of a neutron star might not be insane. The idea of reducing it to the size of a grape or something, or having black holes of 3 million solar masses or something, I think that's silly for a number of reasons. First, theoretical, in terms of where do you get the pressure from, and how do you maintain that much pressure without creating insane amounts of heat. So yeah, just unsustainable. But just the idea of it's just pushing this idea that force is infinite, and it isn't. Pressure isn't infinite. Alright, then another comment. I share your skepticism, same guy. Skepticism about many proven ideas in mainstream science. Yeah, well, this whole the whole theory, Einstein's theory, relativity, they keep talking about how general relativity is established by all this evidence. The evidence is not directly related. The the procession of Mercury's polarium, or whatever, its warped wobble, can be explained without any necessity of bending time and space, by just acknowledging some things that Newton didn't know about, which is the sun's center of gravity moving. And then you get to the bent light stuff, which is really thin evidence, and it's just based on an Einstein arbitrary guess. Let's give it mass, let's not give it mass, let's make it a material thing versus let's make it a force. And I think it's a completely wrong choice. And maybe he needed to do that to make general relativity, the whole time dilation thing work. He needed to warp photons, but I don't think he can warp them. I don't think there's a rule against it either. I mean, I'm not saying it can't be possible, because in my theory it just doesn't really matter. I would argue that the forces don't interact, that force bit doesn't interact with force bit, but the truth is they could, and maybe you wouldn't see it anyway, because then it would be that reflection, like the head-on collision. Is it two things reflecting off of each other, or do the two things go right through each other? There wouldn't be any difference between what rule you established, so it might not matter too much. But I just, for the sake of argument, think the evidence, if it were true that photons could be bent by this force, means they would be bent by magnetism, they'd be bent by electricity, they'd be bent by a lot of other stuff. And the fact that they're not bent by the segregated filtered force kind of just indicates that they're probably not going to be bent by gravity, in my opinion. But anyway, moving on. So dB, standing for something probably. Duty, boo. I like your point around 40 minutes, where you say you can't get away from gravity by moving because of the inverse square law. Yes, so the inverse square law just means that at all points of the radiating sphere, you're receiving the same amount of gravity. So by moving to another location, you don't miss your gravity. It's the same amount going here as it's going to go here. So by moving, you can't change how much gravity you're going to be affected by, how much change in pressure. The change will be equal through that whole 180-degree arc. By moving, because in a sense gravity is instant. No. In a sense, gravity is instant as you move tangentially, say, around the sun. Similarly, it may take light 8 minutes to reach us from the sun, but we see light when we change positions that has already traveled the distance. Yeah, so obviously as you're moving and you're the same distance, the light already left that was going to hit you here, the light that's going to hit you here had already left at the same time. So yes, you're not going to notice any difference in the light. And that has already traveled the distance. Otherwise, when opening your eyes, you would be 8 minutes of darkness. I don't know exactly how that means, but yes. At extreme distances, there would be a time delay in crossing between radial streams, radial? Yeah, that's an A. Sorry. Of photons or gravitons, if considered as particles. So the front of a moving object might get earlier interaction and induce spin. Yeah, but the problem with that is the further away you go, it's such a small amount of effect that the tiny difference, 2 photon difference between this quadrant and this quadrant of the sphere, is going to be so tiny that it couldn't possibly spin something as big as an Earth or something. So I think spin is something that happens earlier in the process, and I think it certainly could be related to what gravity's doing in terms of as you're moving through and you have velocity in a direction, that the fact that you're moving in a direction means you have a bias from one side to the other. Your head has more stuff going this way than your tail has going that way, and theoretically that can give you your twist, because you're going to perpendicularly get rid of the energy in an uneven manner. That is, you're going to eject more energy from the front end has more stuff going this way than you are from the back end that has stuff going that way. So you're going to be pushing more energy in one direction than in the other, potentially. All right. Okay. At extreme distances, okay, we did that. No, I don't. Okay, maybe I did. At extreme distances, there would be a time delay in crossing between radial streams of photons and gravitons, if considered as particles. So the front of the moving objects get earlier interactions and induce spin. Yeah, well, they really won't be earlier, so I don't think that would be the reason. The only reason would be is that the disposition of the matter itself, because it has velocity, is that it has more probability of interactions in the front end than the back end. Light can be artificially emitted and its speed measured. I don't know quite what that means, but unless gravity can be shielded or instantly produced, creation of matter, its speed is under question. Well, I don't think that any speed is under any question. So lots of people have this speculation that they think these constants don't exist, and I don't see any reason to doubt the fact that the speed of light is a constant, and the speed of gravity is a constant, and the speed of magnetism is a constant, because they're all the same thing and they're all moving the same speed. And you just can't make them go faster, and you can't make them go slower, because they only have one function, and that is to go that speed in a straight line, and that's what all these little bits do. If Einstein's curved space concept were valid, is a structure pervading space, as has nothing to do with admission, is gravity therefore instantaneous and its speed irrelevant? Regards. Well, Einstein stipulated that it has the speed of light, so he already stated as part of his assumptions or presumptions or axioms of his theory that the speed of the ether, whatever you want to call his bent space, was the speed of light. So I don't know how you can't really argue that it has a consequence he already said it isn't part of the theory. So the whole idea of it's a God of the gaps theory. I mean, frankly, Einstein's theory it's really kind of, I don't, people just get pissed off because I say something like, it's just cobbled together rubbish. It really is just God of the gaps. It just says, look, here are the phenomenon, and we'll just say an angel did it. A leprechaun. The leprechaun of bent space makes these things happen. And then they go into quantum mechanics and they just create a pixie. And a pixie makes it happen. So there's two different little, the wave pixie and the bent leprechauns. But there's no function, there's no mechanism for any of this stuff. And that's just wrong. Quantum mechanics calls it all virtual photons. It's just such a joke that they're allowed to use that kind of rhetoric. And they even now talk about gravitons, but they're not really, they're not like virtual photons. So I don't know exactly what they are. But anyway. Alright, so, I don't know. Jeremiah something Garcia. No matter is converted into gravity or gravity waves. So I guess he's arguing the LIGO thing. I'm going to eventually play their whole video. I haven't watched it yet all the way through. I've only watched the first 5 minutes, and it's just such crap. But I should do the whole damn thing. and just go through every little bit of it because it's all just such crap. But you can't pretend that's not what they've said. Okay, there was 3 solar masses lost, and they've used rhetoric like radiation created. Now, there's no radiation in Einstein's theory, right? There's no gravity radiation in Einstein's bent space. So I'm just saying they're playing loose with the concepts here. So, I mean, you can pretend that 3 solar masses were converted into distance. I mean, it's expansion of space. Is that what you think? Expansion of space, time? Well, that doesn't make any sense, because then the things would be moving away from each other at the speed of light. And you really couldn't see them then. But anyway, that's a whole nother subject, this Big Bang crap. Not that I'm against the, again, I'm not saying there's not some sort of condensing and expanding universe. But clearly their theory of how they've, again, cobbled together a story is just pitifully poor. I mean, it's Goldilocks improbable. Can we say that? I mean, it's impossible, really. I mean, it's talking bears, with ties and shoes. It's just not reasonable as physics. All right, gravity is an effect that mass has on space. So again, you think that's a convincing argument. You say so. So you say that the 3 solar masses somehow turned into a radiation of some kind, undisclosed radiation, and it somehow affected space by not creating any disturbances locally, though. No, sorry, that is silly. So he says, sorry, but you get off on the wrong foot and keep making errors. What error? So again, you have to point out an error, and to say that you know for sure that, mass tells space what to do, and then space provides mass with a way to do it, or some kind of bullshit, that these things communicate with each other with some sort of special stuff of some kind. You don't have an explanation. This is just talking religion. This is just saying, I know Jehovah is real. I feel his spirit. You're not arguing with a fact of any kind. Just amazing. Wrong foot and keep making errors, mostly which compound from that. So absolutely vacuous as an argument. Just you provided nothing. Nothing. I have a rational theory of a mechanical device that unifies physics. No more quantum mechanics and bent space in conflict with each other. One fucking theory that answers all the questions, and answers all the questions never answered about how magnets attract and repel, how the electrons and the protons attract and repel. And you're going to respond to me with this mush, and this is going to convince me, oh yeah, I'm totally wrong-headed. I'm just being crazy not to just fall in love with this vacuous mush ether theory of the magic ether knows how much the planet weighs, and it knows how much it should move and how fast it should roll. Fuck you. Anyway, so Mad Flea Willing, he says, video coming soon, stay tuned. Yes, brilliant. I'm sure it's the cowboy or something, but sock account 967,433. Go for it. Yeah. Just can't wait. I'm sure it'll be absolutely brilliant. Alright, some sort of Eskimo guy in Samekabebe. A video you requested regarding light, the Big Bangs, and cosmic background radiation. So it's all I can find. Yeah, I appreciate it. So it's a 60 symbols video, and then we talk about it for about 3 minutes in the video, and then they talk about sports or something. It's really silly. But anyway, and it really comes down to, I should have done this a little bit ahead of time. It comes down to this I'm sure some of you anyway, any of you who are a little bit understanding of this physics crap, they have a Big Bang theory, okay, that this is probably not a good enough drawing, but yeah, I have the resolution way down on this camera because it's lagging so much. Alright, well anyway, I guess it goes this way usually. So here's the point of origin is here, right? So it starts off as a little thing, and then it grows a little bit, and then it has this huge, preposterous expansion. So in a millisecond, the whole universe expands, not going just the speed of light, but going bazillions, zillions. I mean, just like I can't even tell you how much distance it is. So much distance. So all of a sudden, there was this gigantic expansion, like 1 million. Like the rest of the expansion that's happened since then is 1% of the expansion. So this one event has 99, let's say 99.9% of all the expansion in the universe happened in this one event. And that's their model. And so that's the only way they can make this excuse for why we could still see background radiation, because they're essentially saying that the stuff moved apart so fast. Let's do it this way. So the stuff moved apart so fast that the light still hadn't moved anywhere. None of the light went anywhere yet. So this happened so fast that none of the light left this and none of the light left this. And so that's why it's taking so long. That's why we can still see the cosmic background radiation, because even though this is like moving linear this way and these two things are getting further apart by a little tiny bit, it's only a little tiny bit. It's a lot slower than the speed of light. So this event happened much faster than the speed of light, and then everything else since then is happening much slower than the speed of light. But the idea is we're seeing it because it never got anywhere. So the expansion was so many billions of times faster than the speed of light that's why we can still see the cosmic background radiation, because it never got anywhere. It never left home, so to speak. And that's their theory. And it's Goldilocks. It's completely made up crap. I mean, it just doesn't make any sense. So there is a way to go faster than the speed of light, apparently, and that is to have a Big Bang where you just make all this huge amount of space fills up and separates everything. Everything just gets hugely separated by huge amounts of distance, just like that, and it's not for real velocity though. It's some sort of space made it happen. So it's another God of the gap explanation. And I'm just amazed that that's the real story. That's what they're going with as an explanation. So we're seeing it because the radiation never had a chance to get to us, because we shot apart from each other so fast that light couldn't keep up with how fast we were going. We moved apart so fast that light couldn't go faster. The matter actually separated. We'll say separated, it's not a real velocity, right? The matter separated. Like we separate from Alpha Centauri, and we separate from whatever, the Crab Nebula, and we separate from whatever's 10 billion light years away out there. We separate from everything so fast that it made light look like it wasn't moving at all. I think that's pretty close to nonsense. Frankly, sounds like something the electric universe people would come up with. All right, on a similar subject, paraplegic. A couple of videos ago, you were asking for a video which goes into the details on the conventional theoretical model of microwave background radiation and its relationship to the Big Bang and inflationary cosmology. So let's understand, they call it microwave background radiation, but it's really in all spectrums. And there's just more of it in microwaves. And the excuse is that it's redshifted visible light, let's say, or more common radiation, and it's been so redshifted that it's now microwaves. But that still wouldn't account for the redshift of the huge expansion in space. So if that huge expansion really did happen, it shouldn't just be microwaves, it should be, long band radio. But anyway, very long band, 700-mile band. Anyway, this live chat by Paul Steinhardt is an uncommonly descriptive discussion of the fundamental physical concepts. So I went to this video and listened to it, most of it, and it's really, holy shit. So this was a guy who was one of the guys who actually invented this stupid expansion theory, and he's now saying it's garbage, doesn't work. And he has different descriptions of he's calling it a bouncing universe and different other things, but he never really gets to the question of how do we see cosmic background radiation when theoretically that radiation should have dissipated by now. I mean, it's not really a background radiation. It happened at the beginning and it should have passed us. Frankly, the expansion of the entire universe isn't that much faster than the speed of light that you could justify saying, let's go look at the see how to say it. You can't look at where we were as at an origin. So it's almost like they're saying that the whole universe everything was in its place, exactly where it is now, and the Big Bang wasn't a bang, an explosion. It was just everything was like this, and everything just grew like this. So there was no force of explosion. So then why would it have been hot? And why would there be energy? I mean, none of it makes any sense. But again, they would have to make that expansion happen much faster than the speed of light, because you can just sort of surmise that there would be a trail of that stuff. The heat part would have all come from here. The heat part can't come from over here, so you can't see it here. So it could never be even radiation. It couldn't be equal on all sides unless you're saying we are still stuck in the middle. Alright, anyway, let's see, physical concepts. So yeah, I didn't, so the video to me was, there wasn't any real description of the argument I was arguing, like where does the cosmic background radiation actually come from, or what's it bouncing off of. But there was this catch that this is a guy who was one of the primary pushers of this huge expansion theory, and he's arguing sort of that it's not right. He's the Albert Einstein Professor of Science and Director of the Princeton Center for Theoretical Science at Princeton University. So the title was World Science U Live Session, Paul Steinhardt. So I'm just saying, if it's it's not easy to listen to. Let me put it's all this theoretical Big Bang stuff, and there's no fun physics in it at all. As far as I'm concerned, it's All right, George Nada. If electrons are performing all the work with photons, i.e. reflections off mirrors and transmission through glass, what actions are the protons doing? Yeah, well, as I've pointed out, the protons are integral to how the electrons perform. And as I've pointed out, the protons are probably essential in terms of steering the force that pushes electrons. The force that the proton isn't affected by is the force the proton actually reflects perpendicularly. So the force that pushes electrons, when it goes into a proton, it reflects perpendicularly, and that idea creates the idea of creating a box. And vice versa, of course, the electron reflects the force that would affect a proton perpendicularly. And so those two relationships are probably equally important. It's just the obvious part is that electricity is as understood more regarding the movement of electrons than the movement of protons. So that's why I think electrons are emphasized more, is because they're the key player, and it's that force between the electrons, the one that doesn't go out perpendicularly, the one that reflects back and forth, is the one that creates the repulsive force between electrons, and that's the place where I think the photons come from. So again, it's sort of more important because it has more to do with what we interact with in terms of the forces we interact with. Alright. Is there a possible division of labor and the protons are only particles reacting to gravity? Your tons, that is, thanks. Yeah, well, which ones are reacting more? I think the trick is the neutron, because that's the dipole. You know, that's the magnet. You know, in every atom, and that's the interesting player, because the neutrons can create that little box really easily. You know, the four corners, the right turns. So two neutrons could create something that can collect velocity, where, as I've argued, protons and electrons can't really collect permanent velocity, but I think a neutron can, and a neutron in combination with a proton and electron can. So anyway, so it gets, there's certainly a lot of detail to go into, you know, in terms of how these things interact and all the structures you can have, crystals, and it's like the difference between the diamond and soot. I mean, it's a huge difference in function out of the same exact atoms. So I'm just saying that, of course, there's a whole bunch of geometry that is all about what electrons and protons are doing. How they're arranged is all geometry, and it's a ton of it to be played with. But I think it's all there. I think that's all it is geometry. I don't know. Some days, you know, you just say, you know, why did you wake up today? Because you can't say geometry. There, okay, I think it's close enough. Anyway, more debunk videos. I already did that. Yes, brain of a P. Yeah, so we did all that crap. I don't think there was anything else of importance. Oh yeah, well the ex-cowboy guy, he did under the name John Wayne or something, he posted some tripe, and I can't remember what it was, but he apparently deleted his comments, or his channel got wiped out again because he's apparently some sort of menace to the rest of the internet also. So anyway, yeah, I guess I don't have to go through too much more stuff here. So, but this should be a, if I, you know, I'll try it on the other computer, do the Windows version of it, and see if I can get the frame rate up a bit and get it to work a little better. See, my mouse does not like scrolling. It's a very cheap mouse, so I have to improve these pictures, of course. And come on, there it is. That's the gravity one. And I have to rewrite the magnetism because I still have the neutral particle in there, which doesn't belong. So, but this is the key thing, is the electron repulsion, is the force trapped between them, the reflections, and as you bring the electrons closer together, you create more reflections, more pressure. That's really the whole game, is that pressure, and this is how the pressure is mediated. It's by this right turn. Is that breaks the cycle of pressure by releasing the pressure. So creating pressure and releasing pressure, that's the whole game, and there it all is between the proton and the electron. The force the electron is sensitive to is released by the proton, and the force the proton is sensitive to is released by the electron. And that's the nature of attraction. And then we have magnetism. This drawing is accurate, I just got to fix the text. So anyway, that's probably enough of a video. See what the file size is like, see how this works. probably out of the frame because I wasn't watching. So, but anyway, I think it might be okay. So till next time and such.